Hello out there. We're missing you. Oh, Kelly's back. That's good. Makes our class a bit better. So, Haydo, hopefully you'll be back soon. Will, Mac, we've left us, and Kunal. I'll be honest with you, I'm not missing the singing. But we do miss you. All right. So what we're just talking about at the moment is we're consolidating stuff, and I don't know if you recalled, but when we were going through some of this stuff, I did ask you to skip. We skipped the 6D, the velocity stuff. So we're going to look at that today, and it's nice. Again, you'll see, oh, look, we did ones like this earlier on. But as you're going through these, I want you to start thinking, and here comes the word that will make you shiver and shake a little bit, shiver and shake. I want you to start thinking of your investigation. Yes, we've got noises, we've got responses there. Now, we're not giving you the task at the moment because you don't need it, but I just want you to put some of these questions as you're doing them. I want you to think about some of the things that you're going to have to do with the investigation. So it's basically that we have a room. Okay, you can choose whatever room you like. I thought it'd be good if you chose the classroom. You could even take pictures of it. But anyway, so you have a room, and in that room there are 2 mosquitoes. And already I don't want to write the word mosquito, so I'm just writing bugs. But they are actually mosquitoes. And they are heading to a destination of your choosing. So it could be that they're aiming in on sweet-blooded Bella. They can smell the sugar from here and go, just had some chocolate. I'm going to get some sugar over there. So are you going to make them both land on her head? Well, that's not going to be very good. Is one going for her shoulder and one going for her ankle? Because you know they always go for the ankle. Or the ear. Wrist, elbow, knuckle. Anyway. But you're going to have to set the direction vector and the speed for these ones. So you can't just go, oh yeah, it's going to take 2 days to go from the roof to Bella's shoulder, right? Gone and dusted. So you're going to have to come up with some reasonable velocity vectors with suitable speed. You are also going to have to get a starting point. Are they on the roof? Are they at the light? Are they at the door? Whatever. Things like that. You're going to have software that will help you do that stuff. So it doesn't have to be that it's all by hand. There will be some cute computer stuff, and there's also on our graphics calculator. Sorry, I'm doing a lot of chatting over there. And the whole point of the task is that you want to try and kill these mosquitoes with one spray. One. And we'll talk a little bit more about that, because if you're anything like my brother, if there's a spider, it's not one squirt. It's like he uses the whole can. Thanks very much for one little spider. Right? So it's one squirt. Now that squirt of spray, you're going to start by saying, well, it's also a vector line. Hence, I'm picking up my squirter. You can't see that. And then you can investigate a different form, like it could be a cone. It comes out as a cone, or a half a sphere, or a plane, whatever. But as we're going to go through and do some of these exercises, I want you to start thinking about, this might be helpful, and I would suggest that you actually start a page of investigate, like just title it investigation, and put little things down there for when we're doing it. Oh, yeah, this could relate to. Does that make sense? So we're not starting the investigation, but as we're looking at some of these things, you're putting it in context. You go, oh yeah, this would relate. Does that make sense? Okay, so we're looking at objects that are moving with a constant velocity, and right off the bat there, when we relate that to mosquitoes, we're going, wow, that's a massive assumption, because we know that they, one, don't move in a straight line, and 2, it's not a constant velocity. So, but we're going to assume that, okay? And for the video, I just love the fact that Christian seems to think that he can sit in this class with his phone out. We say farewell to Christian as he leaves. Okay, so some of the stuff that we already know, it looks like it's a funky diagram, but not really. All that's saying is that your direction vector, right, is going to be hither, and we can add that onto our position vector from the point, and the speed is going to be the magnitude of your direction vector. We know this, I hope. We remember it a little bit, and if you don't, once we have a look at some of these questions, you go, oh, geez, that looked like our little boats that we did. Memory is like the corner of my mind. So find the object's initial position. When does that happen? When t equals 0. And so you're thinking now, ooh, that mosquito, where is its initial position? Is it on the floor? Is it on the wall? Is it sitting on a table? Whatever. So you would have to write a thing like this for your mosquitoes, but of course you're going to have X, Y, and Z because we're going to be 3D. Plot the path. You can use software to plot the path of your mosquitoes. 0, 1, 2, 3 seconds. You might be going 0, half a second, 1, 1.5 seconds, so you could see it. Find the velocity vector. We know that that is 3 minus 4. We're all happy with this. So nothing difficult here. For your mosquito, you will make up your velocity vector. Find the object speed. So we know, just looking at that, what is the object speed? 5, because it's your 3, 4, 5 triangle. And then we can continue on using our vectors. Okay, so you can read some of that stuff if you want to. I thought we would start at, I don't think you're missing anything here. We would start at question 4. And question 5, when we get to that, I would put a little star because that would be, ooh, think and remember this for when you're doing your investigation. Yep. So do you want to work together for a little while or tune me out? I don't mind, shall we? Let's go together because I've missed you. So exercise 6D, question 4. So it's not going to be very difficult. It's just going to make you remember things. One hopes. I was going to palm the pen off to Now and say, would you like to do it on the board? Anybody feel like writing on the board? You lazy Larrys. By the way, my Dyson vacuum cleaner is all set up in its stand, ready to go. I gave it a test run already, but now it's charging and it's got little lights. Tells me what the battery. Oh, bit impressed. Ooh. Equations represent the path of a moving object. T is measured in seconds. And again, how they're writing this is how you would have to talk about your mosquitoes. Little things like, T is greater than or equal to 0. Define it. Distance are measured in meters. Your task will be measured in centimeters. That says that. You could convert it, though, to meters. That's okay. In each case, find 1. So the initial position. Are we going to waste our ink on this? I will. But your initial position is? Right. -4, 3, 0. And please notice, you must start getting specific with your notation. So it kills me in the investigation over the years. If I had $1 for every time I had to say, like students would write, oh, here's your initial position. No. That's a vector, right? The initial position / point has to be a point, a coordinate, so it must be written as a coordinate. So little things, but I'll pick you up on that. And obviously the velocity vector, they're just checking. Well, I don't really know what they're checking. Okay, and of course the speed of the object, I feel the need for speed, that is going to be the 12 squared plus the 5 squared plus the 6 squared, and you could work that out. Now, let's say I wanted it to be bless you, I wanted it to be a specific speed. Let's say I wanted it to have a speed of, I think average mosquitoes travel at 33 centimeters per second, meters per second, I don't know, something there, 33. How would I do that? How would I say, oops, I've decided it's going to have a speed of 33 and in this direction? How would we do that? Silence.
We would say that whatever speed you want is equal to the magnitude of a vector with 3 variables, and then solve for the 3.
I didn't hear a lot of what you said really, but what I was looking for was unit vector. So you would find the unit vector, so you divide by the magnitude, the speed, and then you would multiply by the speed that you actually wanted, because you convert it to 1 meter per second or kilometers per second, whatever it's in, and then you just multiply it by the speed you actually want. So these little things, again, you might be making a note and going, oh yeah, this is what we have to do for my mosquito. And B is basically getting you to do the same thing, but recognizing that your coordinate is here. Ooh, what's your coordinate there? It's missing, 0. And then your velocity vector is the one in front of t. Okay, so give that a go. And what we just talked about of finding a specific speed. That's question 5. So hi kids playing at home, find the velocity vector of a speedboat moving parallel to. So basically you will find the unit vector of that. Oh, it's our 3, 4, 5 again. So we know that 1 over 5 times 4 minus 3, that will have, right, a magnitude now / speed, that will have a speed of 1 unit per whatever, and in this case we're just going to assume that it's the same units, kilometers per hour. So if I want this, so this one is going to be, if I go, let's make this important, so we go, so if I take the modulus of that, we're going to end up with 1, correct? But I don't want 1, I want 150, so all I have to do then is times that by 150. So it'll be 150, people are just staring at me, 150 over 5 times 4 over 3, not over, but the vector was 5 over 30, so 30 times 4 minus 3. You could leave it like that. If you really wanted to, you could write it as 120 minus 90. And how could you check that you were right? Yeah, just find the modulus of that, right, the magnitude, and let's hope that it equals 150. We got a little bit stuck on 7E, correct? So Q's torpedo instead of knocking out. No. So we're saying we need to equate. So we're going to equate our x component here with our x component here, and then we're going to do the same for the y's. So you go ahead and do that. Just stop the video. So we equated the x's and the y's. Hopefully, did everyone else get that? Or am I on my own here? Yes? Okay, so we can use our calculator. Oops, you don't want that. We can use our calculators. 70 plus 4a. Where am I looking? Oh, here. No, I had to bring the a over. Yes.
And then so that's positive 4A.
Yes. But then when I bring it to the left, I've gone to the left. You might have gone to the right. That's Ethan.
If I get the right answer.
Because you went to the right. I went to the left.
No, I just got like
7 minus 4, 20. 7. What were your values? Did you have minus 7, 4 and minus 20? 2 minus 3, 3. 2 minus 3, 3. Is that what you got? 48 on 3. Right, you've just done the negative. Kunal, that's Ethan being a bit of a goober. 48 over 13. And A is, oops, where'd it go? 19 over 13. Now, let's answer the question, because at what time did Q fire the torpedo and when was the explosion? Bless you. So, at 1:34. 1:34. P fires. Yes? And I should go back and put my, so 1.46. What's that? 1.46. Is this in minutes or seconds? So 1 minute. Menu 1. 0.46 times 60. Oops. Oh, 28. Yeah. 28 seconds. And this one will be, do any of you ever use the minute second thing on your calculator? Do you? Very good. Oh, whoops, what am I doing? What was it? 48 over 13. Equals 0.69 times 60. 3 minutes and 41 seconds. 3 minutes. $41. So, from this, those were our two solutions, we? Got to read the question again. From the positive, from the point. A minutes later, submarine fires torpedo. So, P has fired. A minutes later, so 1 minute and 28 seconds later, Q fires. So we have to add on 1 minute and 28 seconds. So at 1:35 and 28 seconds, oh, that's meant to be an S. Seconds, Q fires. Yes? And then 3 minutes and 41 seconds later, explosion. Do I add on the 3 to this, or do I add on the 3 to this? That is the question. Is it?
no, just one.
To the original? So you add on, check the T, la 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 la. Show the position can be written as. No, because that would be, that's your, when it all kicks off for T. I think we add it on to the original.
Yeah, the answer.
You have to do it to the original. So you have to add on now, from this one, you have to add on the 3 minutes and 41 seconds, and that's when the explosion would be. So 1:37 and 41 seconds is when it all goes to hell. Explodes. Kabang! So 8, homework please. If we, and 8E, I'm telling you right now, I went, I had to think about that. It's with the horizontal. But anyway, so we can go through that on Tuesday if you get stuck. But if you end up doing it, oh, well done to you. There was a question there that I was asking. No? Was everyone happy with 6D? How did you do that? Show using vector algebra that the paths of the dots are at right angles. Yeah, dot product equals 0. Who found the angle? So if you tried to find the angle, you could have gone, yeah, 90, but dot product would be your best bet. Well done. You jolly good. Yeah, oui. So have a look at this one now. We're going to end up getting a, whatchamacallit? I believe a formula that will do this for you swiftly, but this exercise is once again a example of C1, you've sort of done them all. But if we think about what's going on, we have our line. We want to find the shortest distance from a point to that line, and we know that that's the perpendicular, right? It can't be any other. We did one like this earlier when we used the quadratic formula. Remember they asked you to create a quadratic? Couple of lessons, was it last lesson? Possibly. And we said, well, hang on. Don't we know too that we can use dot product if it's 90 degrees? And lo and behold, here it comes. Okay, so if we can see here, we've got our direction vector and we've got our point 1, 2. So we're now going to create n is this point here. We call that the foot of the perpendicular, or the n for the normal, right? So our is going to be this point to the line. So any point on our line will be that one. They simplify it, and then you're just going to do the dot product and make sure that it equals 0. Sorry, that wasn't a very good. This one's a better diagram of what's going on. So on this line, at time t, right, any x coordinate will be 1 plus 3t. Any y coordinate will be 2 take t. We happy with that? And then they use the whole position vector-y thing. So we're going to go, let's suss what did they do? Let's suss what this point is here, this vector. You can go NP or PN, it doesn't really matter. Yeah? And so when we take the dot product of that with our actual direction vector of 3 minus 1, it should equal 0. Because the dot product has to equal 0 for perpendicular. And then you just solve for t. You can then find what that point is, and then you're just finding the distance between. And I sort of go, yeah, ho hum, because you will get a formula. But it's cute. Yeah? But again, what is it coming down to? You've got to find this vector, expression for that vector. What do you need to find a vector? You need 2 points. Well, no, that's the equation of a line. We need a point and a direction vector. Here, we need 2 points. They gave you 1 point. How did we get this point? Well, we're saying if we've got that's the equation of the line, any point, that's basically your parametric form, yeah? X equals 1 plus 3t, y equals 2 take. Then you find your vector between those two, dot product with the direction vector that you had here, and away you go. Make it equal to 0. So same thing over and over, right? We've got 10 minutes. Ooh, I really want to give you more, but that's okay. No. So finish question 8. If you want to carry on, you're finishing question 8. Or you might want to carry on with this at the moment. We're doing 6E. You're going to have a go at that, working your way through, but that's the gist. Some of them get a little bit crazy, but it's all right. So let's just try to see how far you get with 6E. But really, what should you be doing? Maybe an hour over the weekend? Don't go nuts. Can we handle that? After you've done this, we carry on and we're then finding the equation of planes. So we found the equation of a line, then we want to find the equation of a plane. And it's nothing tragic. Okay? We find the direction vector of the normal of it and a point. So very similar, nothing stressful. So we're on track, just keep slow and steady chipping away. All good?